The application of zero feed-in is also regulated by standards such as those in the FNN application guidelines. I will now show you exactly what this looks like using an example. For this purpose, I will draw a coordinate system in which the time is plotted on the x-axis and the power in kilowatts on the y-axis. In this case, I also include a minus axis, because the plus axis implies that I'm drawing energy from the public utility grid, and the minus axis implies that I'm feeding energy into the public utility grid. I'm assuming that we have a photovoltaic installation with consumers and will now plot the course of the feed-in or the draw of energy. In my example, we also assume that the draw and the feed-in, that is consumption and generation, are balanced, so that I have no feed-in but also no draw. In the following, I can say that we now assume load shedding for larger consumers. We have existing generation via a photovoltaic installation, and a larger consumer, such as a machine, is switched off in the following example. At this moment, I am producing a feed-in peak. I would assume that it is 100 kilowatts for the purpose of this example. The standard of the FNN application guidelines 4.10 and 4.11 now prescribe that I must adjust this load variation in the zero feed-in within a predefined period of time. Otherwise, it does not meet the requirements of zero feed-in. The standard states that a total of 90% of the feed-in must be balanced in 3 seconds time. To return to my example, I now go to the timeline and enter 3 seconds. Let's say the time here is 0 seconds. This is where 90% of the 100 kilowatts must be balanced. This means that I must counterbalance 90 kilowatts, so that at this point I still have a maximum of 10 kilowatts feeding into the public utility grid. In addition, the FNN guideline also tells me that I must have 100% equalization after 10 seconds. Therefore, I must have balanced the full 100% after 10 seconds on my timeline. To distinguish this from our TSI-HV80, where we have integrated an MIO by means of a real-time measurement, this load variation would actually not be detected and not registered at all, because the real-time measurement immediately signals this load variation and the storage system immediately counteracts it. Then you would see 0 in the curve or on the line. This is in fact the difference between the real-time control of the MIO and the systems equipped with energy meters, such as the TS-HV70. This normative requirement of the 3-second adjustment of 90% is actually a very challenging rule. However, there are still industries in other countries that require significantly faster response times. In this case, we would provide a solution such as the TSI-HV80 with real-time control of the MIO. The benefits of the zero feed-in application are that if the energy supplier should stipulate that only a small photovoltaic installation may be connected, it would still be possible to connect a larger photovoltaic installation due to the normative requirements of zero feed-in. This way, significantly more internal consumption is covered by renewable energy, and therefore a higher degree of economic efficiency is achieved.